Formal charge. We're working out the formal charge in a molecule or ion. Formal charge values can be calculated for each atom in a molecule or ion. This can be used to determine which structure, if there are different possibilities, is the most likely. We call this the preferred structure. If we understand structure, we're much more able to predict properties, and that's what the IB is all about. The formal charge is the charge an atom would have if all atoms in the molecule had the same electronegativity. An equation. Formal charge is the number of valence electrons minus half the number of bonding electrons minus the number of non-bonding electrons. I could say formal charge equals the number of valence electrons, that's the number of electrons an atom began with, minus the number of non-bonding electrons. The atom under consideration still has those electrons, minus half of the bonding electrons. Half because in a covalent bond, two atoms forming the bond will have an equal share of the bonding electrons. The Lewis structure with the atoms having a formal charge values closest to zero is preferred. And this is used to predict which structure is preferred, which structure is more stable from several possibilities. My formula again. Formal charge equals number of valence electrons minus the number of non-bonding electrons minus half the number of bonding electrons. For an oxygen molecule, O2, oxygen in group 16, valence electrons is 6. In the oxygen molecule, we have a double bond, so 4 bonding electrons. Each atom has 4 non-bonded electrons. So my formal charge now on each oxygen atom is given by the equation. Formal charge equals number of valence electrons, 6, minus number of non-bonding electrons, 4, minus half the number of bonding electrons, half of 4. That comes to 0. That indicates a most stable molecular structure. The preferred structure is the one which has atoms with a charge closest to 0. We only count half of the bonding electrons as these are shared between two atoms. Formal charge essentially ignores electronegativity and only considers the arrangement of electrons in the atom. Given the formula. Here I'm looking at SO2. We're deciding on a preferred Lewis structure from different Lewis formulae for a molecule or ion. My equation again. Two structures shown in the table on the left. In the top structure, the oxygen atom in red, that's the one on the left, has 6 valence electrons to begin with. It has 4 non-bonded electrons, as we see, and 4 bonded electrons in the double bond. Formal charge equals number of valence electrons, 6, minus 4 non-bonded electrons, minus 2 for its share of the 4 bonding electrons, giving a formal charge of 0. Sulfur atom. Again, group 16. 6 valence electrons to begin with, 2 non-bonded electrons as we see in the Lewis structure, and 6 bonded electrons. A double bond and 1 single. 3 bonds, 6 bonded electrons. Formal charge. 6 valence electrons minus 2 non-bonded electrons minus 6 over 2 bonded electrons comes to plus 1. And the oxygen atom with a single bond. Formal charge. 6 valence electrons to begin with, minus 6 for the 3 non-bonded pairs, minus a half of 2, that comes to negative 1. Noticing that my overall formal charge is 0, has to be the case because this is a neutral molecule. Second possibility was sulfur making 2 double bonds to each of the oxygen atoms. In this structure, formal charge of sulfur, 6 minus 2 for the non-bonded pair, minus 8 over 2 for the 4 pairs of bonded electrons coming to 0. Formal charge of the oxygen atoms, both in exactly the same electronic environment. 6 valence electrons to begin with, minus 4 non-bonded electrons, minus 4 over 2 coming to 0. This structure is favored, as all atoms have a formal charge of 0. The sum of the formal charges must be the same as the overall charge on the ion or molecule. For example, in the ammonium ion, NH4+, nitrogen, group 15, makes 3 covalent bonds with 3 hydrogen atoms and uses its non-bonded pair of electrons to make a dated bond with a hydrogen ion, came in as H+. This gives the ion the overall charge plus 1. Drawn in the middle as the nitrogen simply forming 4 shared pairs of electrons with 4 hydrogen atoms. The nitrogen atom has a formal charge of 5 for the valence electrons to begin with, minus 8 over 2 for the electrons in the bonds, plus 1. Each hydrogen atom has a formal charge of 1 minus 2 over 2, that's 0. 1 for the original valence electron, 2 over 2 for the half share in the electrons in the bond. That gives the molecule an overall charge of plus 1, I should say ion. Plus 1 is the charge on the ion. The combined formal charges of all the atoms in a molecule or ion should always equal the overall charge. For the nitrate ion, NO3-, again, nitrogen, group 15, shown as making a double bond with 1 oxygen atom, a single bond with the second oxygen atom, and a dative bond to a third. Nitrogen, beginning with 5 valence electrons, now has a half share in 4 pairs, formal charge shown in red, plus 1. The oxygen atom, bottom left, came in with 6 valence electrons, used 2 to make the double bond. 4 remained as 2 non-bonded pair of electrons, giving it a formal charge of 0. Oxygen atom making the dative bond. Again, came in with 6 valence electrons and still has 3 non-bonded pairs of electrons, gained a half share in the 2 electrons making the dative bond, formal charge -1. And my oxygen atom at the bottom. 6 valence electrons to begin with, use 1 in making a single covalent bond to the nitrogen, but gained an electron, shown with the black -1, to give the ion an overall charge of -1. The oxygen, formal charge -1. I could draw that ion in any number of ways. I would still always have an overall formal charge of -1, the charge on the ion, and the formal charge on the nitrogen is plus 1 in each case. Total formal charges are the same for each structure. They're as stable as each other. This is when we have resonance. In a very unusual situation, the assumption made in calculating formal charge, just the same as with oxidation states in redox, all atoms have the same electronegativity. Two structures could be drawn for N2O. One of them with the central nitrogen atom having a formal charge of plus, the oxygen negative, and one as shown, with the nitrogen on the left having a formal charge of -1, the central nitrogen +1. When this situation occurs, the preferred structure is the one in which the most electronegative element has the negative charge. Structure on the left is favored. That's it. If that was useful, please hit like. Please subscribe to be informed of more content.